All right, so this is 9.5 day 2, which is complex number and Demoivre's theorem. So first what we're going to talk about is the product formula and the quotient formula. So this is multiplying two polar complex numbers and dividing two polar complex numbers. So the beginning here says let your first polar number be r sub 1 times the quantity of cosine of theta sub 1 plus I sine of theta sub 1. And then your second polar number is r sub 2 cosine of theta sub 2 plus I sine of theta sub 2. So if you look, they're written the same way. Instead of calling this r and then maybe some other letter, I'm just going to call it r1 and r2 because they're both radius, r values. And then same thing here. This is theta 1, theta 2. Two different angles. Okay, so to multiply your two polar numbers. So if I said multiply this polar number times this polar number, what you would do is you would multiply the r values. So you would do r1 times r2. And then you would have cosine of, and then what you would do with the thetas is you would add them. So theta 1 plus theta 2. And then the rest of it you should know, plus I sine of, same thing. Theta 1 plus theta 2. So how I think of it is to multiply two polar complex numbers, you multiply the r values and add the thetas. Now, when you're writing your final answer, your theta value does have to be between 0 and 360 or 0 and 2 pi. So if it's over 360, you need to subtract 360 until you get it in between 0 and 360. And if it's under 360, you need to add 360 until you get in between 0 and 360. Same thing goes for radians with the idea of being in between 0 and 2 pi. All right, so to divide two polar complex numbers, you could probably guess what the formula is and you would be correct. You're going to divide the r values, r1 divided by r2, the first r value divided by the second r value because it's z1 divided by z2, and then times cosine of, and you're going to subtract your theta values. You're going to do theta 1 minus theta 2. Since it's z1 divided by z2, that's why it's theta 1 minus theta 2, plus I sine of, the same thing. Okay, so here's just a couple examples. We're going to do two examples, one in degrees and one in radians, just to make sure we're okay with those fractions here. So it says find each product or quotient, because I asked you for product and quotient, express each answer in polar form. So we are going to leave our answer in polar form. Now, sometimes it'll say express your answer in standard form or a plus bi form. That just means once you get it in polar form, that means the angle is going to be replaceable. You'll get like the angle's 210 or something, and you could replace that because we know the sine and cosine of 210. All right, so we're going to start with this. We're going to multiply z times w. So z times w, z dot w, z times w, I should say, is, you're going to multiply the r values, so 2 times 6. I don't need the parentheses there, so 2 times 6. And then cosine of, and you're going to add your theta values. So 180 plus 200. Plus I sine of, the same thing, 180 plus 200. I used a bracket around these because there's so many parentheses that I wanted to use something different, so that's why I used a bracket. All right, so now you got to clean this up. 2 times 6 is 12. And then we have cosine of 180 plus 200 is 380 degrees, plus I sine of 380 degrees. All right, so now I could be done, but the only problem with this is because it is in polar form and, you know, it's a polar number. The problem is that my angle is not in between 0 and 360. So I'm going to subtract 360 and I get 20 degrees. So I'm going to write my answer as 12 cis 20 degrees. And yes, you can write your answer as 12 cosine of 120 degrees plus I sine of 120 degrees. That is the same answer, so either one works, but obviously cis form is easier and faster to write. So I will be writing in cis form for the remainder of the notes. All right, now I'm going to do z divided by w, so the first polar number divided by the second number. So you're going to divide the first polar number's r value divided by the second polar number's r value. Cosine of the first polar number's theta, which is 180, minus the second polar number's angle, which is 200, plus I sine of, the same thing. All right, so I have 1/3 cosine of 180 minus 200 is negative 20 degrees, plus I sine of negative 20 degrees. So notice I'm putting those parentheses still in there when the number is negative, when the angle is negative. All right, now negative 20 is less than 360, so I'm going to add 360 to it, and I get 340. So 1/3 cis 340. What I also want you to notice is that this is still in polar form. Cis form is polar form. And the reason that I had you leave it in polar form is because we don't know the sine or cosine of 340. All right, next one, find the product or quotient. Write your answer in polar form once again. So we're going to leave our answer in polar form. All right, so z times w. So we're going to do the r values multiplied, 12 times 4, and then cosine of the theta values subtracted. So theta 1, pi over 4, minus theta 2, pi over 6. Sorry, plus. Plus I sine of, because we're multiplying, right? Pi over 6. Since we're multiplying, we're going to add our angles, pi over 6. All right, so that's 48. And now I need a common denominator to add those two fractions. So my least common denominator that I can get both a 4 and a 6 to be is a 12. So I'm going to write cosine of, I'm going to put down my 12s for my denominators. All right, to get a 4 to be a 12, I'd have to multiply by 3. So I'm going to multiply the numerator by 3. That's 3 pi. To get a 12 to be, a 6 to be a 12, I'd have to multiply by 2. So multiply the numerator by 2. And I get 2 pi over 12. So I have plus I sine of 3 pi over 12 plus 2 pi over 12. All right, so now I'm ready to get my final answer. 48 cis, and then add those two, and I get 5 pi over 12. All right, now we are going to divide those two polar numbers. So I'm going to show you what I can do right here. This work is almost exactly like the work that I would need to do for division, but there are some changes. Instead of multiplying my two values, I'm going to divide them. The first r value divided by the second r value. So that's going to be a 3 instead. Then for my angles, I'm going to do theta 1 minus theta 2. Theta 1 minus theta 2. So I'm going to subtract these theta values. I needed to get a common denominator, and I already did that. So notice I saved myself some time there. So now I can get my final answer as long as it's in between 0 and 2 pi. So I have 3 cis, and that's pi over 12. Once again, pi over 12 is not an angle that I know from the unit circle. The ordered pair I do not have memorized. Same thing with 5 pi over 12 or 340. And I don't know if I'm looking back at this, I accidentally put 120 on this. And I didn't even notice until I was just looking back on my answer. I don't know where I got that 1 from. So let's get rid of it. Boom. Okay. All right, next we have Demoivre's theorem. Demoivre's theorem comes from taking a polar number and bringing it to a power. So if you have the polar number, r cosine of theta plus I sine of theta, and you want to bring it to a power, right? So I want to bring it, like if you look here, that's the polar number to the third power. What you're going to do is you can take the r value and bring it to that power. So I'm going to say to the nth power because that's the power that we're going to say we bring it to. I don't like the way my r looks, so I'm just going to fix it here. Then what you're going to do is you're going to do cosine of, and you're going to multiply theta by the n value, multiplying it by the exponent. So you're going to do n times theta plus I sine of n times theta. Okay, so you're going to take your r value, bring it to the power, and then multiply your thetas by that power. All right, same thing goes that if it's over 360, you want to subtract 360 until you get it in between 0 and 360. And if it's under 360, or sorry, under 0, then add 360 until you get it in between 0 and 360. All right, so this says write each expression in the standard form, a plus bi. So we're not going to keep our answer in polar form. That means that we are going to get angles that we know from the unit circle. Okay, so this says bring the polar number to the third power. So what you're going to do is you're going to take the r value and bring it to that third power. So this is n And this is r right here, and obviously this is theta, and so is the other 80. All right, and then you are going to do cosine of, and you're going to multiply theta by that n value. So 3 times 80 plus I sine of 3 times 80. All right, so now you have 27. Cosine of 3 times 80 is 240. Notice I'm not writing in cis form because I have to convert it to a plus bi form, and it's easier to keep it like this and write it like cis, write it in cis form when you're converting. All right, so now I'm converting to a plus bi form. That means I know this angle 240 right here. So I do know the sine and cosine of 240. So I'm gonna write 240 off to the side. I'm gonna say what the ordered pair is. All right, so 240 is a 60-degree reference angle. So I know it's 1/2 root 3 over 2. I just don't know what my sines are right this second. So think about where 240 is. 240 is in your third quadrant, so that's left and down. So both of those values are negative. So now I can replace, I'm gonna erase this, what I highlighted here. I can replace cosine of 240 with negative 1/2. So I'm gonna do that. This is negative 1/2 plus I times, and I can replace sine of 240 with negative root 3 over 2. All right, so now I just have to distribute, and it'll be in a plus bi form. So distributing, I have 27 times negative 1/2. So 27 times negative 1 is negative 27. And then divide it by 2, which we're just going to leave like that. We're not going to turn it into a mixed number. We'll leave it as an improper fraction. Then we're going to do 27 times negative root 3, which is negative 27 root 3, and then divide it by 2. Once again, 27 over 2 is not simplifiable, so I'm going to leave it. Then I have to multiply that by I. So there is my polar number, sorry, my complex number in rectangular form, a plus bi form. All right, now we're going to go ahead and we have to bring this to the 6th power. Now, what I could do, which would be absolutely awful, is do root 3 plus I times 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 root 3 plus I. I think I said that 6 times. The amount of foiling I'd have to do, distributing, it would just take forever, okay? So what we could do is that if we have r and theta, we can bring r to the nth power, which if you look here, n is 6. And then we can do cosine of 6 times theta plus I sine of 6 times theta. But I need to know what r and theta are, and this is in rectangular form right here. So we're going to convert this to polar form. And I know it seems silly to convert to polar form to convert to rectangular form, but I need to know what those polar numbers are so that I can't get that answer. All right, so let's convert this to polar form first. So we're going to need r and theta. Once we have r and theta, we don't actually have to write it as a polar number. We can just leave it the way it is. All right, so first off, you need to know what quadrant this is in. This is root 3, so that's right root 3, up 1. So I'm going to go right and up, make a point, connect it to the origin, vertical line to the x-axis, right angle, and this angle right here is theta. Now, sometimes I call it alpha, but since this angle right here is theta, I can just call it theta. All right, now I'm going to label my pieces. This is right root 3 and up 1. And now I need to find r. So we're going to find r. R is equal to the square root of a squared plus b squared. This is from yesterday's notes, right? Root 3 squared plus 1 squared. So I have r equals square root of, root 3 squared is 3, 1 squared is 1. So I have square root of 4, which is 2. So I have the hypotenuse is 2. And I know r is 2 now. So I can actually even start to write my polar number squared if I wanted to. So I can say off to the side here, I can do this off to the side. I can do r, which is 2 to the 6th power, times cosine of n times theta. So 6 times, I just need to know what theta is, plus I sine of 6 times, I just need to know what theta is. So I already got r, I need to know what theta is. All right, remember, this is in the first quadrant, so this is theta. If it was in the second, third, or fourth, I'd call it alpha and then figure out what theta is. All right, so let's figure out what theta is here. So I can pick any two sides that I want. I'm going to pick this one, opposite. I'm going to pick this one, hypotenuse. So I'm going to use sine. Could you have done tangent? Of course you could have. Sine of theta is equal to opposite, which is 1, over hypotenuse, which is 2. So this will give me my angle theta. The angle that has a y value of 1/2 is 30 degrees. Okay? Technically, I could say this is a 30-degree reference angle. It's in the first quadrant, 30 degrees. All right, so now I'm going to place 30 degrees right here for my theta value. All right, so let's multiply this out. Or not multiply this out. Let's see what this is. 2 to the 6th power is 64 times cosine of 6 times 30 is 180 plus I sine of 180. Now, if it said leave it in polar form, I'd be done, but it wants it in, I want it in rectangular form, a plus bi form. So now I say, okay, that means I know what 180 degrees is from the unit circle, what ordered pair it is, what the sine and cosine are. 180 is the ordered pair -1, 0. So I have 64 times the cosine of 180 is -1, plus I times the sine of 180 is 0. And now distribute your 64. So 64 times -1 is -64. 64 times I times 0 is just 0. So I get -64. So what that means, if you think about it, is that if I multiply this out 6 times, √3 plus 1 times, watch this, duplicate, √3 plus 1 times, and I did it 6 more times. I don't feel like doing it 6 more times. If I did that and I multiplied it all out, probably would take me about 20 minutes, I get -64. But notice this was a shortcut. Demoivre's theorem is a shortcut. All right, last one here. This is in polar form, so this is not going to take as much work as the one prior. I need to bring this polar number to the 4th power, so I'm going to take r, which is √2, and bring that to the nth power, which is 4th power, times cosine of n, which is 4, times theta, which is 5 pi over 16, plus I sine of 4 times 5 pi over 16. All right, hopefully you noticed that as soon as I realized I was multiplying 4 by a fraction, I made the 4 line up with the numerator. Okay, so reason why is because I can put the 4 over 1, and then I can simplify the fraction. I can multiply and say I got 20 pi over 16 and then simplify. I'd rather simplify first. 4 goes into itself once, 4 goes into 16 4 times, 5 pi over 4. Same thing here, I don't have to show it twice. All right, so we have √2 to the 4th power. So please realize √2 to the 4th power is √2 times √2 times √2 times √2. So √2 times √2 is 2, √2 times √2 is 2, √2 times 2 is 4. Or I would look at it as square it twice. Square √2, you get 2, square it again, 4. Cosine of 5 pi over 4 plus I sine of 5 pi over 4. Once again, you know 5 pi over 4 from the unit circle because the directions say write in a plus bi form. So 5 pi over 4, that is a 45-degree reference angle. So √2 over 2, √2 over 2. But we got to think about what quadrant that is in. So my pi over 4s go 1 pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. 5 pi over 4 is in the 3rd quadrant. That's left and down, so both of those are negative. So I have 4 times -√2 over 2 plus I sine, times I, and then the sine of 5 pi over 4 is -√2 over 2. All right, time to distribute, and I'll be in a plus bi form. So 4 times -√2 is -4√2, and then I got to divide that by 2. Notice that this right here is simplifiable. 2 goes into itself once, 2 goes into 4 twice. So this actually becomes -2√2. Distribute the 4 here, the same thing happens, but I have I in that answer. So -2√2I. And there's my final answer. All right, that's it.